Hey guys, so today we're gonna go over the new part of the third chapter, but before we do that, we're gonna go over one question for the modeling functions part of the third chapter. So let's do this review problem. Anne buys used cars at an auction for $2,000 per car. Okay, $2,000 per car, so that's 2,000x. There is a $150 fee. So fees are only one time, as it says in the question. So it's just a one-time fee of $150. Sorry, I think I said $250. To take part in the auction. If Anne buys 13 used cars, how much does she pay in total? So this is equal to function of x, because x is the variable here, so you put it inside the parentheses. So she's saying that she wants 13 used cars. So it's like, what's 13? How much does it cost? So we're going to first identify the independent variable and the dependent variable. For my graph here, it was dry mix, where this is dependent and then this I right here is independent. So the dependent variable is the y value, or it's also called f of x. And the independent variable is the x value. So in this case, the dependent variable is the total cost right here, total cost. And the independent variable is this x value, which is each car. So it's per car. So it's each car, and that is what the independent variable is. So now we're going to see how much it costs for 13 cars. So in order to do that, since this is car, you just replace a 13 for the x value. Add 150 is equal to f of, and then you would put 13 because that is the variable value. So f of 13. And when we calculate that, it comes to a total of 150.00. That's how much it costs. Always remember to include your value or whatever unit you're using so you don't get points off. Okay, so we just did the review for the modeling functions, and now we're going to go to graphing functions. So graphing functions is actually really important because you need to be able to identify how the graphs look with the x values or the y values that you're given. So I'm first going to tell you all the steps on how to graph functions using a domain of all real numbers, which means all numbers in general. That's not like infinity is not a real number because it doesn't have a value. All real numbers are numbers with values. So step one is, Step one is use function to generate ordered pairs. So ordered pairs, so for example, let's say I'm given y is equal to mx and the m is equal to 2, so y is equal to 2x. So what you're going to do is, let's say they've given you a domain. As I previously reviewed, domain is for the x values, range is for the y values. Let's say you're given a domain of 1, 2, 3. So, as you can tell, since domain is x, these ordered pairs have only the 1, 2, 3, but you need to figure out what the y is. So what you're going to do now is replace this 1 inside the x. So 2 times 1 is 2, so that's the y value. And then here, 2 times 2 right here is 4. And then 3 times 2 is 6. So these are called ordered pairs when it's written like that. Next, what you're going to do is plot these points on a graph. So you're going to you're going to draw a little graph. So 1, 2, 3, 2, 4, 6. 2, 4, 6. So now you're just going to graph them. And then what you have to do is, sorry, my line is supposed to be straight. It just looks a little messed up. So now you just draw a line through to connect them all to prove that it is a continuous graph. So now what we're going to do is I'm just going to give y'all some practice problems that are very similar to what I just showed y'all. Okay. Okay, cool. So the first one we're going to the first one is y equals 2x, but I came up with that on my own, so we're going to do the next one. Y equals 1 over 4x plus 5. And in these examples, they have given us the domain, so we're just going to find the range, and then we're going to just graph the points. Okay, so this is the domain, and so that means these are the x values. So what's the y values? So all we're going to do is plug in these points into that x, and then do the math for this side, which equals the y value. So when it's -8, comma, so -8 plug into 4 would be -2, because when you get the 8 here, -8 over 4 is -2, plus 5, so that's 3. Okay, and I'm just going to do the rest of them. If you want to pause the video now, you can, but I just already calculated them. Okay, so these are the ordered pair coordinates for the graph. So all we're going to do now is go to the graph right here, and we're going to draw them. So -8, -4. That's a little not in scale, but 1, 2, 3, 4, 5, 6. Okay, cool. So all we're going to do is graph them now. Okay, this is supposed to be a straight line. Okay, and that is it. This is how the graph looks for this function. Also, whenever things are in the form of y equals mx plus b, it's always, oops, I forgot the plus. It's always a line because this is the line formula. Okay, we're going to now, since I gave y'all 2 examples of that, I'm going to give just an example of graph the function. You can pick any plots dependent on what you prefer. I normally prefer 1, 2, and 3 plus a 0. Oops, sorry, square right here. Okay. I've written the coordinates right here. I just paused the video and wrote them. It's the x on the first side and then y on the second side. So I did -1, 0, and 1 because you always want to go to a negative value when you are representing something with a square, a cube, or whatever. In general, I just feel like you should do that to make it look like it's continuous. So all I'm going to do now is plot the graph. So this goes to 4. And yes, this is supposed to be curved because it is a parabola. So whenever it's just a mx plus b, it goes to a line on a graph. When it is a like an x squared, then it goes to a parabola like this. When it is an x cubed, it goes to a value sort of looking like this. And there are other examples, but I don't know. I think we don't learn about it in a really long time, so I'll just keep those aside for now. Okay, thank y'all so much for watching. I will review this in the next video and then move on to the next part of the chapter, but I hope you have a wonderful day. Stay safe, and I'll teach y'all later. Bye.